hear about toxic gas detection, wirelessly specifically, which I'm going to talk about. So my name is Jesse Sumstad. I'm a global product manager in our flame and gas division, analytical division of Emerson. So I'll be giving the presentation today. Just going with the theme of this conference, here's Emerson's purpose statement, which is we drive innovations that make the world healthier, safer, smarter, and then more sustainable, which obviously fits the theme for this week. So kind of fitting. This one is going to be more about the healthier, safer than the sustainable. We have a bunch of other good papers that we'll be talking some more about the sustainability, but this is kind of more on the theme. If you're not familiar with Emerson, we're not the Emerson that makes the cheap TVs that you see in Walmart. We're a different Emerson. So we're founded in 1890 in St. Louis, Fortune 500 company. We have about 17 billion in sales. We're broke up into two main business segments: automation solutions, which is part of mine. Then we have a commercial and residential solutions as well. About 84,000 employees. We're a very big company, and we're known on Wall Street as our consecutive dividend increases. So we've never gone backward. Yeah, and then so speaking of the sustainability, the theme of this conference, Emerson, like many companies these days, are committed to lots of different items environmentally. One of our key ones is our reduction in greenhouse gas emissions. So we actually have a target of reducing hours that we produce ourselves by 20% in the next 10 years. And if you'd like to understand this 3 barcode, that's our actually newly created position called the Chief Sustainability Officer. Mike Train is going to be one of the keynote speakers that you'll see tomorrow morning. And basically, we call it like we do greening of, greening by, and greening with. So greening of is like we're making ourselves greener. Greening by is helping our suppliers and our customers, which is where we see the most benefit. And then greening with is like supporting policies and working with local universities to make that commitment. So a little background on our sustainability efforts. So today I'm going to talk about relatively new ways to measure toxic gases. This says Upstream Oil Gas, but I've added a couple more on here with wireless technology. So feel free to ask questions anytime. You don't have to wait till the end. So by the end of this, hopefully you'll understand why we need to measure these toxic gases. Challenges behind traditional toxic gas measurement and the limitations that that has, benefits of using the wireless technology versus a wired technology, basically some basic understandings of the product if you're curious about it towards the end, and just the value that Emerson can bring to you and your plant and workers. If you're not familiar, when we talk about point gas, we look at like combustible gases, toxic gases. It's fairly obvious, but the toxic gases are the ones that will hurt you, hurt your health, kill you, etc. So we're going to be talking about toxic gases today. Okay, so speaking of that, we unfortunately see if we read these stories on the left here, these are actually probably 4 or 5 years old. I could probably go and find some ones that are newer, but toxic gas incidents are still occurring. They occur when they happen. They're pretty tragic, and they're not just minor health issues. They're usually pretty big issues. On the right-hand side here, what we're going to talk today about is CO and O2. And obviously, when we look at the IDLH, or the immediately dangerous to life and health level of H2S, everyone's probably familiar, but it's very low. 100 ppm is pretty low in terms of when it starts affecting you. So you have to be able to detect it very accurately and very quickly in order to protect your employees and your assets. CO, everyone's familiar with that. We have those in our homes as of late. That's a little higher ppm, 1500 TCM or ppm, so it starts affecting us. And then O2, so this one is kind of interesting. So everyone know, who can answer what's the percentage of oxygen we're breathing right now? So 21%, yeah, 20.95%. So really only 1.5% depletion of oxygen. Then you starting to to get into the dangerous zone. So you don't have to have a big loss of oxygen for it to become dangerous. When I first saw that number, I thought it would be a lot lower before it starts hurting you, but really 1.5% decrease, and you start to get in the dangerous zone for oxygen depletion. So with that, some of the applications where toxic gas is present can be challenging to monitor, whether it's costly to get out there, time consuming. Point gas detection in general, there's maintenance. You have to calibrate these and pump test them every 3 months. You have to replace gas detectors, and because of that, you know, there's challenges and reasons why people don't always put these in. And then, unfortunately, sometimes gas detection is often viewed just solely as a cost, even though it's, you know, protecting employees, saving the company's money. But sometimes, you know, everyone's jockeying for money, right? And sometimes these point gas detectors, unfortunately, are just seen as a cost. So like I said, because of that, people decide to forgo these gas detections or do with less effective solutions, or maybe less points. Maybe some even like super remote sites like wellheads will go even unmonitored. People will also just rely on portables, which obviously most people are going to use, but that's more of a, you know, reactive. It may be too late by the time your portable goes off for some cases if the levels are high enough, and so you'd rather be able to know that before you get into a situation. And then also, like I said, maybe you put one up and not enough points of gas detection, or just in general, you don't have enough points out there. So what I'm here to talk about is, you know, why wireless gas monitoring, and really it's all about just getting that alert and that safety into new applications where you might not have been able to, or not been able to justify it. The wireless also allows you to significantly reduce the cost and efforts. I'll talk about like how these things work later, but they run off of batteries and then connect through a gateway that talks to your control system or local alerts or whatever. We usually use like the dollar value of about $10,000. It obviously depends on how remote and or how extreme the wiring is. And that costs come from like IO cards and mainly like the cabling and labor associated with installing wired devices. But there's, you know, even if it's half that, it's still legitimate cost savings that we're talking about when we're using a wireless device. The kind of most obvious is like they're super easy to install. You're just basically hanging them on a pipe mount bracket or putting them on a wall somewhere, and then commissioning them. And then so you need to be able to do that quickly. And then also with gases, you know, some gases fall, some gases rise. So it's nice to be able to mount them close to the floor or up high easily. And that's another advantage of our wireless gas detectors. And then they easily integrate, especially if you have an existing wireless network in your plant or facility. They seamlessly integrate with your existing wireless system. Okay, so now if we look at some specific applications, look at upstream oil and gas. A lot of the focus is going to be on H2S here. We obviously, it's dangerous gas. So for upstream oil and gas, we're looking at remote wellhead monitoring, tank batteries, flare stacks, drilling rates. Like I mentioned, H2S is heavier than air, so you can mount these lower. And then even with like sweet crude oil, there's going to be H2S present, so monitoring for H2S is important. Also, a similar story for H2S for tank farms. So we want to be monitoring for these, especially where the employees are walking, like the walkways, ventilation systems, like the hatches are critical places. Pathways, stairwells, like I talked about, and then other low points within the bunks or dies are important areas to measure for those. Yeah. Moving downstream, away from the upstream and midstream, if we look at the refineries and the petrochemical plants, We have the desalters, feedstock infrastructure, so crude storage tanks. Anywhere the pipelines are where the H2S can leak are opportunities to monitor for H2S and protect your employees or protect your assets. I don't really talk a lot about like O2 depletion here, but those are more for confined spaces and other things like that. So, and this is completely moving away from oil and gas, but there's also a lot of H2S opportunities in pulp and paper plants. So basically, like it's called the craft process, where you're creating paper. You basically take the wood chips and you're separating fibers from the glue, and you liquefy the wood or whatever, and that in itself creates H2S as a byproduct. And then also, there's a part of the craft process is you have white liquor and black liquor is just a byproduct of the process, and they use boilers for that. So the recovery boilers can create H2S, and so people use the H2S monitors to safely run those boilers as well in the pulp and paper industry. Water and wastewater is another big one. Very huge industry, obviously, and I'm not real familiar with this, but there's a lot of H2S concern that are byproducts of cleaning our water and making it drinkable for us. And so we do sell and have these 928, these wireless gas monitors in water and wastewater industry as well. Okay, so that's kind of the background of where and why we need to have these toxic gas measurements. And now I'll just jump into our product a little bit here. And so basically a couple of years ago, Emerson created we call it the 928, which is this wireless toxic gas monitor that you see here. And so, like I said, the upper right here, the hydrogen sulfide, carbon monoxide, O2 deficiency, those are the three gases. We have more gases coming out, combustible gases, ammonia, chlorine coming out. But really, this product is just an addition to the vast wireless infrastructure that we already have around the globe. You can see we have 10 billion hours of our wireless devices running over 32,000 networks around the globe. And so this is just an addition to that technology as well. Okay, so the form factor, this kind of shows like three main things, but the product on the left, you can actually see right here is the actual sensor itself, which I'll talk about in a little more detail. And the piece on the left is, we call it a puck, maybe it's because I'm from Minnesota, but the puck there is the part that you can take out one-handed without any tools. Technicians don't need any tools, but you can take that out and swap it. No hot work permit required. You can take that out and bring that back to the lab to calibrate it in the lab. So you don't have to do any calibration out in the field, like on a hot, humid day. You don't have to be out there with a handheld device doing your calibration. You can bring it back to the lab and do your calibrations there. And so all the calibration data is stored in the sensor. So that's where either the H2S or the CO or the O2 cell is going to be. Basically, that snaps into the bottom of the transmitter, which is a standard transmitter wireless antenna. That's an airtight seal it creates there, and you can sort of see right kind of the size dimensions of this transmitter. It's pretty small and how it works. All right, so the technology itself is nothing mind-blowing or new. It's just electrochemical field sensor technology that's used in a lot of, obviously, wired point gas detectors. We've just, obviously, like with their phones and everything else, wireless battery life is a huge thing. And so, the part of this project that made it work was figuring out how to use an electrochemical cell with limited power. But the technology is just like your standard electrochemical cell. you have kind of a filter on top, so the gas can come in through the top here. That's just keeping out dust and dirt. You have, these 3 electrodes: the sensing electrode, a reference electrode, the counter electrode, and then it's surrounded by electrolyte. What happens is the gas diffuses through that filter, it goes into the cells, and it oxidizes, reduces, creating a tiny microamp signal, which can make a linear line to parts per million of whatever gas. So depending on the gas that you're sensing, the electrolytes and the electrodes will change to work for that gas. And you don't need I should have mentioned the back one, there's not a different transmitter needed so you could take, if this was an O2 one, you could swap in an H2S one. They're not, the transmitter is specific for gas. Benefits, like I said, this technology's, electrochemical's been around for decades. It's very repeatable, very reliable, accurate, and obviously specific in parts per million range. I don't need to stand up here and preach that technology. Different form factor. But then because it does have this electrolytes in it, there are conditions. So essentially once that sensor gets made, it's going to go 1.5 to 2 shelf life. Depending if it's in a super hot environment, it will be reduced as well. You can kind of re-energize it a little more length out of the sensors if you're kind of swapping them and using them every once in a while. You'll get a little extra life, but they do. That's one kind of limitation of this technology. And then there is some cross sensitivity to other gases. I won't go into the details here, but we got tables that explain the ppm and the cross sensitivities for the other gases. So it's just something to be aware of, that in some certain applications, if you have those other gases, there's some sensitivities. And like I said, high temperature, sensor where it sees gases more is going to shorten the life. So yeah, this is just the kind of highlighting what I talked about before. We have the transmitter here. That's the high view. Here you can see the puck that gets inserted into the transmitter. We got our electrical board with the sensor on top. Like I said, it's a smart the 628, which is what we call the puck, is smart. So there's no calibration in the field, calibration in the lab. Bring it back to the air-conditioned room and do your calibration there. So, and then wireless HART. So there's a couple of different wireless communication protocols. Wireless HART being one of the more predominant ones, but this allows fast and easy commissioning and troubleshooting. It allows remote access to the device. There's a huge, obviously this product would be way more interesting and beneficial to you if you have an existing wireless network, but setting one up is not hard. It just requires a gateway, which you see over here on the right, which is what the, I didn't even put it in this network, but the way that these wireless devices work is called a mesh network. So they kind of talk to each other to get back to this gateway, go around walls, or sometimes it's not like a line of sight. It's a mesh network where they're kind of bouncing off each other to get the signal back to the gateway here. And so that's how our wireless networks work. And the distance between these two can be fairly large. I think it's like a mile or mile and a half range for those. I'm not exactly sure, but I know it's a long distance. And like I said, they're self-organizing and self-healing. So, and I think when these first came out, people were worried about security, but that's not an issue as well. So remote configuration, you can use, this is like a hazardous area handheld, basically like a tablet that we use for configuring our product. Otherwise, you can use software rather than PCs to configure the product. And then this just shows, kind of another architecture here, what the 920 would be. mounted gateway connection to like your DCS or PLC. So yeah, we don't have to have power on the left side, just power to gateway to here. All right, so just kind of a recap, the 928 wireless gas monitor helps you extend these entering the challenging applications. They're not meant to replace a portable, they're meant to augment the portable monitors. They, you know, in theory, give you a, one thing I did say is there's discrete output on the 928, so you can have flasher alarm going if it does detect gas, besides going to a control system. So if someone's walking up to something, they can tell that the gas is present. You can easily adjust the location, of course. And then, I didn't talk about it a lot, but some of these gases are damaging or detrimental to your equipment. So besides just protecting your personnel, you can be alarmed to potential, you know, shorten the life of your equipment, and or even more importantly, like a process that is upset or interrupted. This is an indication, even if you haven't saved or indicated a gas detection for employees purpose, you at least know that something's gone wrong, something's broken, and then you have a gas leak. So some wins that we've gotten. So some major oil and gas in North America. So up in the Bakken in North Dakota, the customer needed to monitor issues on its well pads, trials, and we're using those on that, which has worked out well. We have water and wastewater plants in Singapore that are using these to measure H2S, kind of in the basement of one of the buildings to improve safety for the employees. And then, as I talked about earlier, some petrochemical plants in China where they basically had no measurements were easily able to put these in where they had an existing wireless network, just to create a safer environment. And so I've been talking about the product on the right, which is wireless point gas, but we also have wired point gas. We have an INCUS, which is ultrasonic, so like listening for leaks. If you have high pressure gas, this thing will detect leaks in multiple directions. We also have open path gas detectors and flame detectors as well. So if you have any questions about that stuff, feel free to reach out to me as well. But yeah, we offer the an entire for the flame gas stuff. Any questions?
Jesse, it seems to be like this would be ideal for turnaround situation where you have a large milk coming into that, and you want to bring in monitoring so that you can ensure their protection, although they may not have personnel for detectors.
Absolutely.
So this would be a good thing. You can bring it in locally, set it up, and then when the turnaround's over, take it off and bring it for us.
Absolutely, for sure. Yeah.
So is there an alert that says when it reaches shelf life?
I think there is a.
Or do
I don't know. I'm almost positive there is. This is a good question. Sorry. Hey,
I was just wondering how that alert gets notified. Is it through AMS or goes to your mobile phone and says, "Hey, replace this pop"?
I think it's a heart signal that's sent out that you could set up, I guess. But sorry, no.
No worries.
Sorry, just what was the question about the battery?
No, how does it know when the sensor has reached its life? Yeah. The battery does that?
Yeah, so the battery have a up from the battery size, so you can all the batteries send the information or alarm information about the battery status.
But this is on the sensor status with regard to shelf life.
Yeah.
But does it have an alert with respect to that?
The battery when
No, not the battery.
No, I don't know because I said I thought it was all the battery and just asked to operate the battery.
So when you guys, off test or periodically go around and test the sensors with a test gas?
I mean, that's
That's,
recommended is every 3 months, right?
Yeah. So that's usually when you catch the sensitivity of it all.
Do you already mention the detection unit for entities?
No, I didn't. Sorry, I just took over this product like a month ago, so I literally, I apologize. I need some, I need
Probably,
to.
it's probably 10 ratio.
What was it?
Your alarm setting is probably 10 dBm ratio best.
Yeah. Okay. Thank you.
I do have a question. So the connection, so the product's interesting, but I think the challenge is the connection to the PLC. Can you talk about any cybersecurity issues with kind of the wireless system and you're connecting basically into your brain facility?
Sure.
So is that something that you guys have dealt with at all or been
Yeah.
going on?
Can you help me, Marcio, on this? The security. In terms of,
For the wireless communication, it's not based on IP address, so just that is issue. And so the wireless protocol, right? So it needs to match from one transmitter to all to get the destination, right? So on the transmitter, yeah, it's a small package and secure. The question is more of the say when you are hooking up the gateway system to your Ethernet or that, right? So then that is pretty much all the careful or the good practices that you have with IoT systems. So firewalls, all that thing applies as any other device. Well, there is a Teams publication or a new release for firmware, for gateways, etc. So that all complies with regulation. Busy here to work, but to keep up the
security updates.
yeah. Yeah, sure.
All right. Well, thank you for coming to this. Yeah, thanks for your comment. I didn't think there'd be this many people at the 8:30 on the first day. Yeah. Guess it was. Yeah. Let's picture about 4, so thanks for coming.
Yes.
I apologize. So I'm coming late. My name's Christopher Almashu.
I literally. I've got a couple. Thanks. Got my own job on there, so. I literally took the slide deck. I don't know if that's. Yeah, he gave us a presentation. Took the slides and practiced them about twice, so I'm not.
Yeah, I think I'm product manager. Yeah. Over at QV.
Yeah.
So, yeah, exactly. So. God, I'm missing it. So I'm sorry.
No problem. Yeah. So what?
Yes, Thursday, 4 o'clock. Same as you. This gas detection.
Yes.
So we don't. 20. Massachusetts, just outside of Boston, Martown, Mass.
It's like also like, oh, so someone got popped, someone, so like, but yeah, you guys are original.
involved in and in coordination with a couple of key customers, who end up deciding not to use it. But we do a lot of the same applications you guys do. Say, or
Oh, yeah,
yeah.
yeah.
So,
For what?
yeah. I'll show you what we have there. But a couple projects in Emerson kind of fit together.
Yeah,
I don't know if you're aware of that.
yeah. Oh, nice.
How fast looked at the agenda, so I just wanted to get you. But
Yeah,
you around all?
yeah.
Right, good, that's what I mean. Okay, good. Yeah, so
We're going to present this tomorrow. I'm sure you've seen this presentation.
Yeah, I saw this one, yeah. You know, I'm.
It's a very much calling you.
Yeah. So when I'm doing, I'm talking a lot of different applications that we've done successfully. So it'd be great if you were there. One, you can see what we've done, but also so you can kind of share your experiences or see if you can get some experience from what we've never suggested.
Sure.
Just so you can, what I'd like to do is have more, be less presenting and
Yeah.
discussion. So I'd love for you to kind of bring in your own experience.
Yeah.
So I guess we have to figure out.
Yeah,
So I'll see you before I just got running around.
absolutely. Thank you. Thanks for helping me out.